Hello everyone and welcome back to your YouTube channel. And today I have a bit different video. It's different because today I will talk about a power system analysis software that is called Interactive Power System Analysis and also called Ipsa. Ipsa is a power system analysis software that it was developed in order to perform several power system calculations. This software started in 1972 at the University of Manchester, former UMIST. It was originally in 1974 was a PhD project. And after that, this software has been developed. Ipsa was the first power system analysis software that in 1972 include a fully functionality graphic interface unit. And the software started with basic functionality for static analysis, and then transient stability functionality was added in 1972. And the first commercial version of the software, it was in 1986. And from there, well, the software has been increasing in functionalities and also in the market inside the GB system. And today, my video is dedicated to show you how to download this software. But we will start first with a short description classification of the power system analysis software. And from there, I will show you some examples of different non-commercial software, open source software, and then finally we will discuss some commercial software. And the last section of this video will be showing how to download Ipsa, and from there we will move on. Well, let's start this presentation. As usually, I would like to clarify that I don't have any commercial relationship with any of the companies related with software or hardware that I present at my YouTube channel. Also, it's very interesting for you that you can go to the ResearchGate. I have a ResearchGate profile, and in that ResearchGate profile, you can download several slides related with this presentation. Also, I have a GitHub repository, and over there you will find several of the practical applications or examples that I use in my videos. If you are watching this video, it's because you are watching YouTube. And if you are in my YouTube channel, please subscribe or leave a comment, and I will be extremely happy to help you and answer your questions. Finally, if you would like to be informed about the research, development, and innovation that we are carrying out at the lab, please feel free to subscribe to my social media, specifically to my Twitter account and LinkedIn. Well, let me clear the screen, and now it's time to start this very different video. As you must be aware, there are many power system analysis software. And the first thing that you must to understand is that the software is basically a calculator. Yes, a power system analysis is a calculator. In a calculator, you can use this calculator in order to solve some arithmetic calculations. Plus 2 plus 2 equal 4. Is something similar with the power system analysis software. The main difference is that you are dealing with power systems, and inside those digital environment, you have the possibility of calculating some of the most important power system analysis. But now, how do we classify the power system analysis software? Well, from the economic point of view, from the access point of view, we can consider two main groups. We can consider the commercial power system analysis software, and they are non-commercial software. The non-commercial software is probably something that you must see around, and non-commercial power system analysis software, they are computational programs. And in those computational programs, they can be freely distributed, but that doesn't mean that they are open source. I mean, when we are talking about non-commercial power system software, there are some of them that they are fully open source, and there are others that they are closed source. But it's very interesting that you understand open source versus closed source. The open source is basically any software, any program that the application or the library in which you can get access the code. I mean, in open source, you have the possibility of accessing the source, the code, make modifications, improvements, and so on. But on the other hand, in closed source software, in those cases, you don't have that freedom. You cannot modify the source code. Of course, each one of those approaches, they have advantages and disadvantages. If you are a researcher, if you are a person that tries to develop the next generation of power system analysis, probably you are interested in doing some open source programs. However, be careful, because open source software, that means that anyone can put the hand on that code. And as a consequence, it's quite typical and quite frequent that those open source programs, time to time, they have bugs or they have some small problems. Be careful, because also all those open source initiatives, they are basically collective initiative, and as a consequence, the process of validation and debugging can be a problem. That is the reason that many software developers, they prefer to go for the closed source, because the programmer, the main programmer, is responsible for the security, for the quality. That means the development, debugging, and validation of the software. Well, as you can imagine, there is something called the commercial software. And the commercial software, of course, there are some money involved in that kind of software. Of course, there are many companies that they are fully dedicated to develop power system analysis software. And generally, those commercial software, they are fully closed, and as a consequence, the user has not the possibility of modifying the original code of the program. However, many of the commercial software, I will say a lot of the commercial software used for power system analysis, right now they have an interface, an API, that allow the communication with a third-party software. That is the reason that many of the commercial power system analysis software, they are using Python as a way to communicate with other software, and that allow the user automation or creation of new functionalities. And again, commercial software, they are created by companies. Of course, those companies, they have some commercial objectives, some profit, but those commercial software, we have the guarantee, we have the full guarantee that the software has been developed, in a proper way. As a consequence, the debugging, validation is something that is taken care of. I highly suggest that you use legal version of those commercial software. Because when you are using an illegal version of a software, first, you are committing a crime. Because in the majority of the countries worldwide, is a crime using illegal software without the legal license. But more than that, there is a ethic, a moral program, a moral problem related with the use of those illegal software. Because every time that you are using an illegal license for a software, what you are doing is decreasing the economic income of those companies. And those companies invest a lot of money hiring the most talented programmers, power system engineers, in order to develop the proper solutions. And when you buy a commercial software, you are 100% sure that you are getting a product that will solve the problem that is intended for. For that reason, please use always a legal version of the software. Well, here in this table, I would like to show you a very short list about different open source power system analysis tool. Here at the very top, you can see one of the famous, that is the GripLab D, that is coming from the U.S. Department of Energy in the United States of America at the Pacific Northwest National Laboratory, PNNL. This software, GripLab, is basically dedicated to power distribution system as modeling and simulation. Another of the very famous open source power system analysis software is OpenDSS. In the lab, we have published several papers using OpenDSS as co-simulation platform, specifically for power distribution systems. This software is very serious and very well maintained by the people from EPRI, the Electrical Power Research Institution that is based in the United States of America. Here at the very end of this table, you can find the different links that you can access and get more information or even a copy of those open source programs. Modelica is a very interesting language. It's designed for model complex physical systems. And there are several libraries dedicated for power system. Panda Power is another of the open source power system. Panda Power combines the data analysis from the classical Python library Pandas, but also use the power flow solver coming from another Python-based solution, PyPower. If you want to get more information, well, you can go to Panda Power, that is basically created, developed, and maintained by an institution in Germany that is called Kassel, University of Kassel. MatPower is also one of the very well-known open source power system analysis. This is a MATLAB language based that is free for use and is an open source that is basically for solving steady-state power system simulations and also optimization. Here at the very end of the table, you can find the website that is basically matpower.org. Another very well-known software is Power System Analysis Toolbox. It's a MATLAB toolbox. That means that is installed inside MATLAB, but it's basically allow the simulation of power system analysis and simulation. There is a command line version of PSAT also for GNU Octave. If you want to get more information, I believe that our colleague and friend Federico Milano, he is still having at the website at the University of Dublin, he is still having and maintaining some information regarding this software. And finally here I have PyPower for Dynamics, that is an open source transient stability simulation program that it was created in Python. Well, this is a very limited list. You can go to internet, you can go to many places, and you can get more information about open source power system analysis tool. Now what I will show you here is a limited list of the commercial power system analysis tool. And at the top, you can see here Dixieland Power Factory. To be honest, the original name of the software was Dixieland, and all of you must know that is a digital simulation of electrical networks. However, over the time, the database and the functionalities inside the software, they changed, and the concept of Power Factory started. There are other software like Aspen, that is a software that is based on Windows, that have a special emphasis for power system relaying. Many of my colleagues, in Mexico, Dominican Republic, and many other countries worldwide, they are quite adapted, and they use a lot Aspen for protection. Also, CYME is another software, is an integrated suite with modular power engineering applications. There are some modules for distribution system, for protections, for grounding, and so on. Another of the very well famous software is ETAP. ETAP is a software that is basically for modeling, design, analysis, optimization, and predictive real-time solutions. There are a lot of resources at the website. I highly suggest that you go over there. General Electric Energy also have a positive sequence load flow software that is called PSLF. That is the short for positive sequence load flow. Ipsa is another of the software designed for integrated power system modeling and simulation. PowerWorld is also another very famous software. There are a student version, there is a demo version. It's very visual, very simple to use, is very well used, especially in many universities in North America, in the United States. Another German software that you can identify is PSE and also Syncal. They are coming from Siemens, PTI, and is basically the initial for power system simulator, that is PSS. And PSS has an integrated suite for many power system analysis functionality. But today I have something relative new for you. I have here this software that is called Ipsa. Ipsa, as I said before, is a software for a company that is called TNA, that is located in Manchester. And as I said before, this software, Ipsa, was created as a PhD thesis at the University of Manchester in 1972. And from there, this software has been used in many of the local utilities here in England, and it's still developing and increasing the capabilities. As you can see over here, I have a short screenshot of the website. You can see here the address, the location, the website location, and you can see that there is a trial version that is for 14 days. What I will do now is I will go to the website and I will show you the very specific place that you can download the software. And in the future videos, I will be installing and I will be presenting some of the main functionalities of this software. Well, let's start with the download. Okay, right now we are at the Ipsa website, and what we are doing is going inside the Knowledge Hub. And inside the Knowledge Hub, you will get inside about Ipsa, the training and videos, or the educational cases. There are a lot of information, but also downloading the installers that they can be for Windows operating system, but also for Linux, okay? And there are some documentation in PDF file format that you can download related to the release notes, installation mechanism, license agreement, and also several user guidelines related with keyboard shortcuts and reference to the plugins and the manual. And also there are some technical notes dedicated for more technical information related, for instance, for the conversion of the conversion tool, or the models or per unit quantities. There are a lot of information in this website. What I will do now is I will download the version 2.10 for Windows 64 bits. And right now I am download that one, and it will be very fast depending of course of the internet connection that you have at your place. Okay, then I will download another version, the 2.9, for my personal records. Again, it's a 64-bit in Windows. And also I will download the version for Linux. Okay, as you can see, there is a Linux version for 64 bits, and is relative compact installer, because you can see it's less than 100 megabytes for the installation. Then I will start to download all the documentation that I can see over here. It's very important that you take time. In this case, the release notes. It's very important that you take time and read all the information in order that you can see the evolution of the software and the critical information for the single user install. As you can see, Ipsa has the possibility of installing a single user, but also there is a possibility for network connection. And in this case, there is a setup for network that you can download the PDF file and you can learn more how to install the software using a network license. Finally, I think the last document over here is related with the end user license agreement. The end user license agreement is very important in order that you can understand what you can do with the software and what you can't do with the software. It's very important in order that you know the scope of the contract and the license agreement. Okay, I highly suggest that you download, take time, and carefully read about those details. Also, there are some user guidelines, for instance, for dedicating and know about the keyboard shortcuts, the reference guides, the plugins, and I will start to download all of them inside a very specific folder that I will call user guidelines. Okay, user guides. And inside that I will store those PDF files, because later I will have a proper reading of them. I will keep downloading those files, the reference guide, and from there it's a very short download to 2.2 megabytes. And from that, I will keep downloading documents. I will speed up this process in the video. I download all the PDF file. Right now, I am speeding the video in order that you can see that I am doing the process, but taking less of your time, okay? My idea is download all those PDF files because they are technical information, especially the technical notes. They provide you information about how the software is calculating and how the software is solving. And that is a very important information if you want to have a proper understanding of the software and how to use the software. And here we are downloading many of those, including calculation of per unit, dynamic model for the transformer, line ratings, and so on, and including also the calculation DC decay for the short circuit currents. And now I will go to two important sections, one for videos. You can go to that very specific website, and there are videos about Ipsa, protection, Ipsa, load flow, interfaces with Ipsa. I highly suggest that you take your time and watch those videos and be familiar with the use of the software and the additional information. But also, if you are interested in a formal training about the software, well, you can go for the section of trainings and you will see that Ipsa is providing several training courses. They are linked over there and you can go there. Well, this is almost the end of this video. In this video, I show you the power system analysis software, the classification in commercial and not commercial. Non-commercial software are typically used for research. There are many researchers around the world taking advantages, but also there is a possibility of interfacing a commercial software with another software using Python. And today I discuss the concept of Ipsa, this software developed at the University of Manchester as a PhD thesis in 1974. And Ipsa has been a software used here in the UK, especially for the distribution system operators in the southwest England. And I show you how to go into the website, how to download the installer. I download the installer for the Windows version of 64 bits. And I also download a lot of technical documentation in PDF file. Well, this is the end of this video. I hope you enjoy, and I will see you at the next video. Thank you.